In this video, we're going to take the averagely performing Sunloo Filler Dryer S1 and modify it to max out its filament drying potential. Now you may be thinking, why is he modifying the S1 when the S2 is on the way or possibly even out by the time you watch this video? Well, I've seen the S2 and some early reviews, and it seems all they've really done is put an extra heating element over the top and slightly increase the temperature that the inside of the box can get to. Now, in my opinion, that doesn't really address the fundamental flaw with the S1, which is now carried over to the S2, in that the box is virtually sealed when you're heating it, so none of the moist air can get out. As soon as I can get my hands on an S2, I'll obviously check it out and let you know how it performs. In the meantime, like me, you may wish to modify your S1 to make it potentially even better than the S2 is from new. We'll see. We saw in my Sunloo S1 review video and in my Sunloo S1 versus my filament dry box video that the Sunloo S1 is capable of drying foam, but it's let down by the fact that the moist air is trapped inside the box. It all condensates on the inside of the lid and is still there when the heat gets turned off. We even saw in one of my tests that opening the box slightly while the heater was on actually seems to reduce the humidity inside the box. This is probably because the moist air is allowed to escape and dry air can replace it. Anyway, let's put some of these theories to the test before we go modifying any parts. First off, we're going to leave everything standard. We're going to put a piece of foam loaded with 30 grams of moisture into the box and leave it on heat for 24 hours. At the end of this test, by weighing the foam again, we can see that 15.34 grams of moisture has been removed from the foam. Unfortunately, as we've seen before, it's now all over the inside of the box. Now, I don't know about you, but I don't particularly want to put a sensitive roll of filament inside this box at the moment. Next, we'll repeat the same test, but we'll open the box a bit. At the end of this test, we've actually been able to remove 25.94 grams of moisture out of the foam, with not a drop of condensation in sight on the inside of the box. Thirdly, I wanted to see what would happen if we kept the box closed, but put some kind of desiccant inside to absorb all of that moisture and take it out of the air. I designed and printed some small containers to put some silica beads inside of, and then put one inside the roll and then one up in the top corner of the box. This time, after 24 hours of heating, we've removed 18.8 grams of moisture. Not bad, and an improvement over a closed box with no desiccant inside, but still a little way short of the open box. If you're enjoying this video, then remember to like and subscribe. I make videos just like this one to help you with your 3D printing and other projects. If you subscribe, then YouTube will take me more seriously, but more importantly, it will help you get the content you want and need. Okay, so at the moment our best option is still to leave the box open a little bit while the heat is on and then close it once the heating cycle is finished. Now obviously we could come up with some sort of complicated mechanism or arm that kind of opens the box at a set time, but that just all sounds really complicated and I like to keep it as simple as we possibly can. So instead I'm going to cut a hole in the back of the box and run an extractor fan. The idea being that this fan draws the moist air out of the box and pulls in drier air through any other gaps in the box anywhere. I'll need to wire the fan in a way where it comes on when the heat is on and then goes off when the heat stops. However, obviously on its own that won't be enough because when the heat does stop and then the fan stops, any moist air could get drawn back through the fan. So I need a way of closing off the fan when it's not running. So instead I've designed and 3D printed a flap vent that the fan can push open when it's running, but when the fan stops, gravity will close the blades and kind of seal the box up. Certainly to a point where very little moisture would come back through. So as long as the fan removes all that damp air that normally causes all the condensation of the inside of the box, we're onto a winner. In testing this setup, you can see that the fan does open the flaps, but only a little bit. This might be okay. If we want the vent to open more, we're going to have to create some sort of intake vent somewhere because there's a bit of a vacuum being created inside the box and restricting the flow. So how are we going to wire up this fan so that it turns on and off with the heat? Well, my first attempt was to wire the fan in parallel directly in with the heating element. They're both 24 volt, so I thought this might work. It did work, but after a few hours it was clear that whatever signal the element receives was not suitable for our fan. The first fan died, and just to be sure, I wired up and fried another one. So a slightly more involved circuit's going to be necessary. Just inside the box at the back of the plug where the power comes in, we've got a permanent 24 volt feed. If we were to wire our fan directly to this, then the fan would be on anytime the mains plug is turned on. That's not ideal though, we still want it to come on and off when the box heats up. We don't just want it on permanently. The simplest method I could think of is a normally open thermal switch in series with the fan. Depending which thermal switch you select, they either open or close a contact at a specific temperature. I bought a handful of different temperatures and tested them out so you don't have to. I found that a 55°C thermal switch tucked down the side of the element at the back is perfect for turning the box on and off when the heat gets anything above about 45 degrees. Personally, I always run my box at 55°C anyway, so the lower temperatures don't really bother me. But if you do want the fan to come on at a temperature lower than 45 degrees, then maybe think about using a 40 to 45 degree thermal fuse. Just bear in mind that the lower temperature thermal switch you use, the longer it will take for the fan to go off and therefore close the box after the heat goes off. Right, let's test it. I'm pretty hopeful that this one will be an improvement on the closed box and desiccant tests. But if we do get any improvement on the open box, we're not going to see it with only a 30-gram piece of foam. That one removed 25 grams, so if we get any real improvement over that, we're not really going to see it, 'cause we'll just absorb all the moisture. So I'm going to use a piece of foam with 60 grams of moisture in it, just in case. As the test gets started, there's no sign of condensation in this one, and the relative humidity is also really low, especially when we compare it to the closed box test. The Sunloo's telling us that it's not reaching its target temperature of 55 degrees, so we'll see if this affects anything. After 12 hours, the foam was looking pretty dry, so I couldn't resist a sneaky check. Amazingly, after only 12 hours, the foam was 43.7 grams lighter. That means that the extractor fan mod is helping remove 3.64 grams of moisture per hour. There was no point in continuing the test because obviously the foam would be completely dry within another 4 to 5 hours. Here you can see a comparison of all the tests represented as grams per hour and listed in order of performance. The standard box drying rate was 0.56 grams per hour. The desiccant beads managed 0.78 grams per hour. The open box was 1.08 grams per hour. And the extractor fan mod was 3.64 grams per hour. This means that this simple extractor fan mod makes the Sunloo S1 6.5 times more effective at drying the foam than the standard unit is out of the box. I was also surprised to see that the extractor fan also makes the box over 3 times more effective than just simply opening the box. I imagine this is because when we open the box, it's only open halfway and there's still a lot of moist air in the top that's trapped there, whereas the fan takes the air out of the top of the box. Right, I'm sure like me, you're fed up of seeing little bits of foam, so let's actually try and dry some filament now. ABS is known for being pretty hygroscopic, so I bought the cheapest roll I could find on Amazon and then abused it for about a week. I basically put it in all the places you really shouldn't put filament. Well, no, not all the places you really shouldn't put filament, but you know what I mean. I left it by the shower for a few days and I put it in the kitchen for a few days too. Obviously I've got no idea how much moisture was already in the filament when it came. All I do know is it came in kind of like a cellophane shrink wrap and I'm pretty sure that wasn't airtight. But after my week of abuse, this 750 gram roll gained 8 grams. After 24 hours in our fan vented Sunloo, the filament lost 10 grams. This obviously means that the 8 grams of moisture that I added through my abuse got taken out, but that another further 2 grams of moisture were removed from the filament. This must have already been in the filament when it was delivered to me. And this is why I'm putting so much effort into making the best filament dryer and storage solutions that I can. If filament's being delivered to us already damp with moisture, what hope have we got of getting consistent printing results? I think we can safely say that if you want to get the best performance out of a filament dry box, then this mod's really worth doing. Let me know if you think there's any other mods that I could have done that I've missed. This series of videos was suggested and effectively financed by you guys, my subscribers, so let me know if there's anything else you want to see. If you haven't seen how the standard Sunloo S1 compares to my filament dry box, click this video here. This video is one that I think you might like, so check that one out too. Thanks for watching.